straight into it. Point number 1. During chemical reactions, materials are changed into new materials with new chemical and physical properties. Chemical reactions occur when elements or compounds combine to form new substances. So, let's give an example of this. For example, I was baking and I was baking a cake, so I needed like 2 eggs and butter and flour and baking soda, right? But in the end, my cake is delicious and it is, has more mass than, flour or eggs on its own. The egg doesn't taste like the cake in the end, right? The cake is sweet and you don't taste the egg at all. So the same thing with chemical reactions. In fact, every time you cook, there's a chemical reaction happening. Every time you breathe, there's a chemical reaction happening. Every time you think, there's a chemical reaction happening in your brain, right? So in a chemical reaction, we take elements or compounds and they bond together to create something new in the end. An example is water. So we start with hydrogen atoms. Hydrogen and oxygen are both gases, all right? So 2 gases will combine to form water, which is a liquid, all right? That's quite miraculous. So in a chemical reaction, we know that energy cannot be lost or energy cannot be created or gained, right? So the same with a chemical reaction. No atoms are lost or gained during a chemical reaction. They're simply rearranged, right? It's like puzzle pieces. In the beginning, you have a whole lot of puzzle pieces dumped into one, and then you need to rearrange it into that perfect picture. Just like this chemical reaction over here, we have hydrogen on one side plus oxygen, and in the end they don't look like hydrogen and oxygen. They look like 2 mini mouses together, right? This means that the number of atoms on one side of the equation must equal to the number of atoms on the other side. So if I count the number of oxygens on this side, there are 2, and there should be 2 oxygens on this side as well. If I count the number of hydrogens on this side, there's 4, so there should be 4 hydrogens on the other side as well. Okay. All right, so when this happens, we say that the equation or the reaction is balanced, okay? Because we have the same number of atoms on one side that we have on the other side of the equation. Okay, so let's move on. So guys, when those materials that have to be broken up and rearranged to form something new, those are called reactants. Those are the ones we start with. And they are usually on the left-hand side of the equation. Can you see there's a plus sign here and then there's an arrow? But on the right-hand side of the arrow, we have our products. Our products is, like we say, the final product. That is what you get at the end of the reaction, when the bonds that are holding oxygen together and hydrogen together are broken up and reorganized. All right. So the next thing we're talking about is that there are 3 ways of representing chemical reactions, right? So let's look at water. The first picture that we have here is a molecule of water. The second picture is a glass of water, and the third is the scientific formula for water. Which one is correct? Which one represents water? Tell me in the chat. Which one is the best representation of water? Okay, Christopher says H2O. Anybody else? Okay, so guys, the truth is, hello, there's no real proper representation. They all are correct. Whether you represent water as a molecule, as a picture, like number 1, or you represent it as a picture of water, it's the same thing. Or you represent it as symbols or chemical name, the formula, right? I'm just adding Mulemo in the chat. And who is Duzu Beast who said hello? Hellos. Oh yeah, so I think we're missing Kian from this chat, eh?
My name is Kian.
Is it Kian? Hi Kian. All right, so let's move on. If you've missed part of this video, I will be uploading it, so you need to check it out there. So just to reiterate what I already said, we can represent a chemical reaction in 3 ways. We can represent it using words or symbols, right? So instead of saying H2O, you'll just write water. We can represent it drawing the molecules itself, or what we imagine we imagine atoms to look like, or on a macroscopic level. A macroscopic level is a large level, so actually taking water, and that's how we can represent it. But for this lesson, we're going to focus on the 3 ways. We're going to focus on pictures, words, and symbols. So if we were to represent a chemical equation using a picture equation, I'm just reading here. The diagram below shows that the atoms in 2 hydrogen molecules, H2, and who can tell me why are hydrogen atoms bonded together like that? Why is there two here and then 2 here again? The same with oxygen. What do we call those kind of molecules? Where in nature, there are 2 atoms bonded together. Yes, Christopher, well done. So because hydrogen and oxygen are diatomic molecules, that means that they exist as 2 atoms in nature. You will write the formula of hydrogen as H2, right? And oxygen also goes as O2. On the left-hand side, rearrange to form the 2 water molecules H2O on the right side of the arrow. Hydrogen atoms are white circles and oxygen atoms are red circles, just so you guys remember. Okay, so what is the product of the above reaction? Tell me in the chat. The product is what you get in the end, and write it for me as a chemical formula, not in words. What is the product of the above reaction? Yes, the product is H2O. I'm only getting answers from Christopher. Why is that? I want all of you guys to help answer as well. Okay, and then the reactants are hydrogen and oxygen. Okay, moving on. Our second way to represent chemical equations is by using word equations. So I'm reading. For example, when hydrogen gas reacts with oxygen gas to form water, we can write a word equation for the reaction as follows. So we're just taking hydrogen and we're writing it in words. So there's no symbols in a word equation. We start from hydrogen plus oxygen, which gives me water. And another name for water is hydrogen oxide. And do you know how we get hydrogen oxide? If we look at the formula here, we start with H2. H stands for hydrogen, and because the name is ending with O, we put an IDE. Okay, moving on. And the last type of reaction that we find is a chemical reaction. When you look at the reaction equation below, you will notice 2 kinds of numbers. The first number is called a coefficient, and they exist in front of the chemical equation, right? So if we look at the equation over here, all the numbers in green, I'm actually going to not highlight this so I don't confuse you guys. But all the numbers in green that come before the compound are called coefficients. And the smaller numbers, the ones in red, those are called subscripts, right? Let's learn a little bit about what they mean. So a subscript in red shows us how many atoms there are in one compound, right? So let's look at H2O. Let's ignore the 2 there and just look at the red subscript. This tells us that there are 2 hydrogen atoms in one molecule of water, right? And we know that there's an imaginary 1 next to oxygen, so there's also 1 oxygen atom in one molecule of water, right? And when we come to the green numbers are called coefficients, and they tell us, okay, so they tell us how many compounds or how many molecules there are of that compound. Let me show you a picture equation quickly. So if we look at this again, it says there's a 2 before H2O, right? That simply means that there are 2 molecules of water, all right? There's a 2 before hydrogen here. This means that there are 2 molecules of hydrogen. Same thing here. There's an imaginary 1 before O2. That means that there's just 1 compound of oxygen. Okay, so is everyone understanding, or do I need to recap?
Yes, ma'am.
Okay, awesome. So just to revise a little bit. Good guys. It's great that you understand this, because this is the foundation now of everything we're going to be doing onwards. So the green numbers that come before the compound name tells us how many molecules of that compound there is. Remember, a compound is like water or carbon dioxide, right? A molecule is the smallest part of that compound. So these Mickey mice are molecules, right? So because there's a 2 before H2O, it tells us that there are 2 molecules of water, and therefore I've drawn it at the bottom. All right, let's do another example of a chemical reaction. Okay. So in this case, we start with 2C. That just means that there are 2 atoms of, what is C? Is C chlorine or is C carbon? Tell me in the chat. Good. C is carbon, right? Good, guys. So I have 2C plus 2O2. So in this case, it means that there are 2 molecules of oxygen atoms. Right now, remember, oxygen is a diatomic molecule. Therefore, you have 2 in one molecule. 2 atoms in one molecule. And we look at 2CO2. CO2 is carbon dioxide. And the 2 tells us how many compounds there are, right? So we see there's 1 and 2 compounds of carbon dioxide. All right, this should be pretty simple. If we look at the red numbers here, we see that in O2, there are 2 oxygen atoms in every one compound, okay? So when we're looking at this, we need to ignore the 2 there. Just imagine that didn't exist. In every oxygen molecule, there are 2 atoms, right? When we add a number before, and I'm just coloring that in green, it tells us that there are 2 molecules of oxygen now, right? I'm going to draw it. So this is 1 molecule, and this is another molecule, okay? Same thing with carbon dioxide. There's a 2 before, so here's 1, and here's another one. And if I had to write it as a word equation, what would I start with? So type the word equation in the chat. All you need to do is take the picture equation or take the chemical equation and derive words from that. So let's see. Let me help you guys a little bit. We start with this compound here, which is this element rather. Yes, Michael.
Sorry, ma'am. It was an accident.
Okay. So good, Mo. Well done. So we start with carbon plus, and we have oxygen. In word equations, we don't need to worry about saying how much of each thing there is, right? Which gives me carbon. And what do I get in the end, guys? Carbon dioxide. Good. Dioxide. So you guys have just given me the word equation, and we have a picture equation and a chemical equation, all three in one. Okay, if we move down, we have an activity for today. It says complete the table below by stating what type of equation each one is. So this one's a picture equation, then you guys will tell me the rest, right? Just add it in the right-hand column. Number 2 says, when does a chemical reaction occur? Just give me the definition of chemical reaction. When something and something bond to create something, right? What are the 3 ways to represent chemical reactions, and why is it important that chemical equations or reactions are balanced, right? Tell me about how energy can't be lost or gained, that kind of stuff. It's all within your notes. And this is due for tomorrow, guys. It shouldn't take you more than like 10 minutes to do this. Yeah, I hope you guys learned, and we will continue the lesson tomorrow.